Every day, people send messages, log into accounts, shop online, transfer money, and store private photos in the cloud. It all feels normal until you stop and ask a simple question: how does any of this stay private? The internet is not a private place by default. Information moves through networks, servers, and devices you don't control. Encryption is the invisible layer that makes modern digital life possible without constant fear of someone peeking into your data. What encryption is? Encryption is a method of protecting information by turning it into unreadable code. In normal form, your data is plain text, meaning it can be understood by anyone who sees it. When it's encrypted, it becomes scrambled into something that looks like random characters. The only way to make it readable again is to use a correct key, password, or decryption method. Without that key, the data stays locked, even if it gets intercepted or stolen. Why encryption matters? Encryption matters because it protects the things you care about most: your identity, your money, your private conversations, and your personal files. If someone intercepts an unencrypted message, they may be able to read it instantly. If they intercept an encrypted message, they see only unusable data unless they also have the key. That difference is huge. Encryption also reduces unwanted tracking and surveillance by making it harder for unauthorized third parties to view what you're doing online. In a world where digital information is constantly moving, encryption is what helps maintain trust. Encryption you use every day. Most people use encryption daily without realizing it. Messaging apps like WhatsApp, Signal, FaceTime, and iMessage rely on encryption to protect conversations. Banking apps use encryption to secure logins and transactions. Secure websites use encryption to protect what you type into forms, especially when it involves payment information or passwords. File storage services often encrypt documents and photos so that even if data is exposed, it's far less useful to attackers. Even encrypted USB drives exist for situations where you want an extra layer of protection on files you carry around. How encryption works. At the core, encryption converts your data into a scrambled format using an algorithm and a key. The key is what controls the transformation. When information is encrypted, it is locked using the key, and when it is decrypted, it is unlocked back into readable form. You can think of it like putting a message in a safe and locking it. Anyone can find the safe, and someone might even steal it, but without the correct combination, they can't open it. That's the basic logic behind encryption. Even if data is exposed, it remains unreadable without authorization. Symmetric encryption. Symmetric encryption uses the same key to encrypt and decrypt data. In other words, one secret key locks the information, and the same secret key unlocks it. This method is fast and efficient, which is why it's widely used for protecting data at scale. The challenge is key sharing. If two people or systems need to communicate using symmetric encryption, they must both have the same key, and that key must be protected. Asymmetric encryption. Asymmetric encryption uses two keys instead of one, a public key and a private key. The public key can be shared openly and is used to encrypt data, while the private key is kept secret and is used to decrypt it. This is useful for secure communication over the internet because it allows systems to exchange information safely without needing to share a single secret key ahead of time. Many modern security systems use asymmetric encryption during the initial connection, and then switch to symmetric encryption for speed once a secure channel is established. What end-to-end encryption really means. End-to-end encryption is one of the strongest privacy protections in everyday communication. It means the message is encrypted on the sender's device and only decrypted on the receiver's device. Nobody in the middle can read it. Not your internet provider, not hackers intercepting traffic, and not even the company running the messaging service. That's why end-to-end encryption is often described as only the sender and receiver can see the content. It is designed to reduce trust in middlemen and put privacy directly in the hands of users. How to tell if something is encrypted. A simple sign of encryption online is Hypertext Transfer Protocol Secure in your browser's address bar. Websites that use HTTPS encrypt the data traveling between your browser and the website, making it much harder for outsiders to intercept passwords, payment details, or private information. Many browsers also show a padlock icon to indicate that the connection is protected. Apps may directly state that chats are encrypted, sometimes with an encrypted label inside a conversation. If you're dealing with sensitive information, it's worth checking these signals and researching the security practices of the service you're using. The relationship between passwords and encryption. Encryption protects data, but passwords often protect access to that data. That difference matters. If encryption is the lock, the password is often the key you use to access the locked system. This is why weak passwords can ruin strong encryption. If someone can guess or steal your password, they may be able to access encrypted content through normal account access, even if the encryption itself remains technically unbroken. That's why two-factor authentication is so valuable, and why password managers are widely recommended. Many password managers encrypt your stored passwords, but they rely on one strong master password to protect everything. Common myths that confuse people. A common myth is that encryption is only for technical experts. In reality, most encryption is built into apps and websites automatically. You're not expected to understand the math behind it to benefit from it. Another myth is "I have nothing to hide," which misunderstands privacy. Privacy isn't about hiding criminal behavior. It's about controlling who has access to your personal life, your finances, and your conversations. Another misconception is that encryption slows down devices. Modern hardware handles encryption efficiently, and most users won't notice a performance difference. What life looks like without encryption. Without encryption, the internet becomes far more dangerous. Messages could be read mid-transit. Payment information could be stolen while traveling between you and a website. Logins could be intercepted, leading to account takeovers. Public Wi-Fi becomes especially risky without encryption because attackers may monitor traffic on the network. Even businesses face major damage when they fail to protect user data properly. If a system routes private messages through an insecure point, one weak link can expose everything flowing through it. Pros and cons of encryption. Encryption is powerful because it makes personal information unreadable to unauthorized people. It strengthens privacy across communication, banking, and browsing, and it reduces the damage caused by data interception. The biggest downside is that encryption can also lock out the rightful owner if keys or passwords are lost. In some cases, encrypted data cannot be recovered if the key is gone. Another limitation is that encrypted systems can slow down investigations because law enforcement may not be able to access content easily. Still, for most everyday users, encryption is a net benefit that protects real-world safety, finances, and identity. How to get started with better encryption habits. A practical way to strengthen your online security is to use services that prioritize encryption by default, especially for messaging and file storage. You should avoid entering sensitive information on websites that don't use Hypertext Transfer Protocol Secure. Enabling strong account security through unique passwords, two-factor authentication, and trusted password managers helps protect encrypted content from being accessed through simple account compromise. When using new apps, it's worth checking whether they support encryption properly before trusting them with private information. If you enjoyed this video and want more simple explanations of powerful technologies shaping our lives, make sure to like and subscribe. Thanks for watching, and we'll see you in the next one.